viewers, welcome to my channel. Today in this video we are discussing about alpha beta pruning and the previous year NTANET question based upon alpha beta pruning. So this is a question which was asked on July 2017. So before explaining this question, we have to know about what is alpha beta pruning. So to study alpha beta pruning, we have to know what is minimax algorithm. I have done a video based upon this minimax algorithm. So please check my playlist so that you can easily solve this question. So alpha beta pruning means it is a modified version of minimax algorithm. And in minimax algorithm, we have searched all the nodes. Okay, we have searched all the nodes. But in alpha beta pruning, we are only searching certain nodes. Okay, we are eliminating. We are eliminating certain nodes. That is called as pruning. Okay, that is we are checking only few nodes. Where we will eliminate checking certain nodes. Okay, so that property is called as pruning. So it is achieved. This technique is achieved based upon two parameters. So that is called alpha, and the second one is called beta. Okay, so the alpha is called a maximizer and beta is called a minimizer. Okay, so alpha's property, that is a task, that is a duty of alpha, is to hold the maximum value from the lower nodes. Okay, from the lower nodes, and min's property is to hold minimum value from the lower node. Okay, and here there is a condition for alpha and beta, that is alpha should be greater than or equal to beta. That is a condition in alpha beta pruning. Alpha should be greater than or equal to beta. Okay, so let's check out some example, so that just one example. Okay, so that you will be familiar with the alpha beta pruning and you can easily solve that the question in the previous year question paper. Okay, so here the gameplay tree is given and you have to find the value in the root node. Okay, and here the result of minimax algorithm will be same as that of alpha beta pruning. Okay, if the question is to find the root node, then the root node will be same. Okay, in case of if you are using minimax algorithm, the result will be same as that of the alpha beta pruning. Okay, so let's solve this problem. So here the question is to find the value of the root node. Okay, so just like we have discussed in the minimax algorithm, this root is a max, then min, then max. Okay, we start with the root node, then traverse and reach the terminal node. Okay, so a terminal node, the node is 3. Okay, so here that value 3 is passed to the node D. Okay, so alpha is a parameter which is used in the max and beta is a parameter which is used in min. Okay, so here the condition for alpha is alpha should be greater than or equal to 3. Okay, so then it check the next node. Okay, so that is 5. Okay, so we have to get maximum from these two nodes. Okay, 3, 5, among 3, 5. So maximum of 3 and 5. What is the maximum of 3 and 5? 5, is it? So the node D's value is 5. Is that clear? The node D's value is 5. Okay. Then that value 5 is passed to node B. Okay. So here what is the condition for beta? Beta should be less than or equal to 5. Okay. Then by using traversing it reaches the node 6. Terminal node. Okay. And then that value is passed to node E. Okay. So what is the condition here? That is alpha should be greater than or equal to 5. Because here why we are using alpha? Because alpha is a parameter which is associated with max. Okay. So at this point you notice that the value at node D is 5. Okay. And sorry, this is 6. Okay, because terminal node is 6 and that value is passed to node E. Okay, so alpha should be greater than or equal to 6. And you notice that this is a subtree. Okay, and node D is 5. Okay, so node E here it is written as alpha should be greater than or equal to 6. Okay, so what is the value of B? B means minimum of node D and node E. Is it? Minimum of D comma E. What is the value of D? That is 5. What is the value of E? If it is 6, then 5 will be taken as the value of node B. Is it? If it is less than 6, okay, if it is less than 6, then node E will be, there is a chance that node E will only take that 6 value. That is, so now the value of E, suppose the value of E is 6. Okay, because 6 is passed to node E. Okay, suppose the value of A is 6. Okay, then if this node, that is this 9, okay, if we have to, if we are considering this node, that is if we are considering this node, this 9th node, then the result at node B will not change. Okay, the value of node B will be always 5. If we are considering 9, then there is no change for the node B. Okay, if we are not considering 9, then also the value of node B will be 9. Okay, so hence we are not considering this node 9. Okay, we are prunning that value. Okay, we are prunning that value. We are not using this. Okay, so the D and E. Okay, D's value is 5 and E's value is 6. Okay, so minimum of 5 comma 6. What is the minimum of 5 comma 6? 5. Okay, so node B is 5 now. Is that clear? Node B is 5 now. And now that 5 is passed to node A. Okay, and here what will be the condition? Alpha should be greater than or equal to 5. Okay, then traverse and reach node 1. Okay, and now we check the maximum of 1 and 2. Okay, currently alpha is 1, alpha should be greater than or equal to 1, and then we consider next node, that is 2. Okay, and the maximum among 2 is, that is 2 and 1 is 2. Okay, so the node f is 2 and that value is passed to C. Okay, C is minimum, so beta should be less than or equal to 2. Okay, so here also the node B is 5. Okay, node C is 2. Okay, so at node A we are taking the maximum of 5 and 2 because here it is given as maximum. Okay, so maximum of 5 and 2, the answer will be 5. Okay, so there is no need to consider this, because if we are considering this node also, if we are considering this node, then there will be no change for the result. Okay, then there will be no change for the result will be always 5 in this case. Okay, so we are pruning that path. Is that clear? So here I will explain once more. That is, initially we start from 3 and alpha's value is, alpha should be greater than or equal to 3. Okay, then we consider the node 5, then 5 is greater than 3, so the node D is 5. Okay, then that value is passed to B. Okay, so that condition is beta should be less than or equal to 5 because the min is specified here. Then that so beta should be less than or equal to 5, then we traverse and reach 6. Okay, so here that value, sixth value, is passed to E, node E. Okay, so what is the condition there? Alpha should be greater than or equal to 6. Okay, then we are not considering this 9. Not considering this 9. And we are not considering 9, and the minimum of 5. So now the node D is 5 and node E is 6. Okay, the minimum of 5 and 6. What is the minimum of 5 and 6? 5. Okay, so the node B becomes 5. Then that value is passed to node A. Okay, so what is the condition there? Alpha should be greater than or equal to 5. Okay, then by traversing we reach 1. Okay, then the maximum of 1 and 2. What is the maximum of 1 and 2? 2. Okay, so node F becomes 2. Okay, so node F become 2 and that value is passed to C. Okay, so now the condition is, because beta minimum, there is minimum, and so the condition is beta should be less than or equal to 2. Okay, and here we are not considering this path. Here we are not considering this path because it will not make any change for the root node. Okay, because at root node, at root we are finding the maximum of 5 and 2. Okay, we are finding the maximum of 5 and 2. But that is, what is the maximum of 5 and 2? The 5 will be the result. Okay, so root node will be 5. Okay, if we are considering this, okay, if we are considering this, then it will not make any change for the root node. Okay, so we are not considering. Okay, suppose we consider this node. Okay, what is the maximum of 0 comma minus 1? What is the maximum of 0 comma minus 1? It is 0. Okay, so node G will be 0. Okay, and then minimum of 2 and 0. What is the minimum of 2 and 0? 0. So node C will be 0. Okay, so then maximum of 5 comma 0. What is the maximum of 5 comma 0? It is 5 itself. Okay, there is it doesn't make any change for the root node. Okay, so we are not considering this path. Is that clear? So this is alpha beta pruning. So we pruned which path? We have not used this path, we have not used this. Sorry. This and this. Okay, 1 2 3 4. This we are not used. Okay, in minimax we have to consider all the nodes. That is the difference between minimax and alpha beta pruning. In minimax we have to consider all the nodes, but in alpha beta pruning we are not considering all. Okay, so this is how alpha beta pruning works. And now we can move on to that question, NTANET question. Okay. So there is a question. Here the root is a maximizing node. Okay, so the root is max and this is min, is it? And we have to visit the nodes from left to right. Okay, so what nodes will be prunned by the alpha beta pruning? So here we have to consider the nodes which are prunned. We have to consider the nodes which are prunned, okay, that are not visited. Okay, the nodes which are not visited, we have to find the nodes which are not visiting. Okay, so we start from which node? We start from node D, because using DFS traversal we reach node D. And now the condition should be here minimum. Okay, so the parameter used is beta. Okay, so beta should be less than or equal to 3. Then we consider 12, then we consider 8. What is the minimum value? 3. Okay, so node B will be 3. Then that value is passed to A. Okay, so what will be the condition there? What is the parameter used there? Alpha. What is the condition? Alpha should be greater than or equal to what? 3. Okay, then by traversing we reach G. Okay, so then that value is passed to C. Okay, so what is the condition there? That is minimum. Okay, so beta should be less than or equal to 2. Okay, so what will be the value of root node? That is the maximum of 3 and 2. Okay, maximum of 3 and 2. What is the maximum of 3 and 2? That is 3. Okay, so if we consider these two nodes, suppose if we are considering these two nodes, what will be the value of root node? If we consider these two nodes, what will be the value of root node? That is a minimum of G, H and I will be the root, will be the node C. Is it? Okay, the minimum of G, H and I will be node C. Okay, what is the minimum of G, H and I? That is 2. Okay, then for root node we will find maximum of 3 and 2. What is the maximum of 3 and 2? 3. Is it? So if we not consider these two nodes, then also the result will be 3. Okay, if we are considering these two nodes, then also the result will be 3. Okay, hence we will not consider these two nodes. So the value of root node A will be 3. 3 means maximum of 3, that is B comma C. Okay, what is the maximum of B comma C? 3 comma 2. Okay, so the root node becomes 3. Is that clear? Okay, I hope you understand this. Thank you.